Alright, so on the integral of secant to the fourth x, or secant x to the fourth, I should say, looks kind of scary because we have a trig function. We're integrating a trig function, and a trig function is raised to some power, but it really isn't that scary because let me show you. I'm gonna do a big brain move real quick. I'm gonna rewrite this as the integral of secant squared x times secant squared x. Right, this is all the same. The 2's and the exponents add up to 4. I didn't really change anything, I just re-expressed it. So secant squared x times secant squared x. We know we have a trig identity that says tangent squared x plus 1 is equal to secant squared x. We have a trig identity that says that. So what we can take one of these secant squared x and replace it with tan squared x plus 1. And I'll show you why we're doing that. So let's do that first. We have integral secant squared x times tan squared x plus 1 dx. Alright, now we can break the integral apart, right? Break it across this addition. Well, first distribute the secant squared x and then break it apart, but you know what I mean. So we have integral of secant squared x tan squared x dx and plus the integral of secant squared x dx. Alright, now this is really cool because this integral we know how to do, right? This integral we also know how to do because we have a function right here, right? We have tan x, and that's a square, but we have a function tan x, and we have its derivative right here, secant squared x. That's easy. I mean, that sets us up for a crispy u substitution. So this I'll leave off for now because that's easy. That's just tan x. And I'm gonna be working on this integral, right? I'm gonna say that u is equal to tan of x, right? And then we're going to differentiate both sides. So what's the derivative of tan of x? That's secant squared x, right? So we get du is equal to secant squared x dx. Look at that, we got a secant squared x with our dx, smash them together to make a du. And then u is equal to tan of x, so we end up with the integral of u squared du, right? That's easy, power rule. So we end up with u cubed over 3, right? Now unsubstitute, if that's a word, doesn't matter. And we'll end up with tan cubed x over 3, right? I'll bring my work over here now. So we know this integral, we know the value of this integral, this is tan cubed x over 3, right? We know the value of this integral, integral of secant squared x, that's a standard integral, that's easy, that's tan of x. So our total answer, our final answer, whatever you want to call it, is going to be tan cubed x over 3 plus tan of x. And never forget the constant c. So that's basically it. Looks kind of scary, the integral, but if you just break them up into secant squared x, use the identity, you can set yourself up for a crispy u substitution and get a pretty cool answer like this. So yeah, that's basically it. Stay tuned for more cool stuff.